Okay, good morning, good afternoon, and good evening, everyone, and welcome to our BT Diamond IP webinar. I'm Michael Dooley, Vice President of BT Diamond IP Operations, and I'll be your host on today's webinar. Today's topic is Taming Hybrid Multi-Cloud Chaos. Cloud computing enables IT and operations teams to provide network computing and services capacity with flexibility, efficiency, and elasticity. But it also presents an additional network domain for IT administrators to track, secure, and manage. With the proliferation of networking and computing environments spanning on-premises, hosted, private, public cloud services, you need to manage your IP address space and DNS assignments consistently across all of these disparate domains. Whether you're leveraging private or public cloud services to provide persistence services diversity, or whether you cloud burst to expand your capacity, you'll need to track your IP resources to ensure network integrity, especially in light of your need to manage all of your IP addresses resources consistently across all your different domains, public, private, hybrid, cloud, or non-cloud. Today's webinar will feature a 40 to 45 minute presentation discussing these topics, followed by a brief question and answer period. To ask a question at any time during the webinar, you may type in your question in the chat pane on the WebEx application. We will hold all questions until the end to maintain the flow of the presentation. We're happy to have Tim Rooney with us here today as our presenter. Tim is our Product Management Director and is responsible for directing product and feature development, supporting sales, marketing, supporting product-oriented organization functions. Tim has co-authored several books with myself covering such topics such as IPAM, IPv6, and DNS security, all published by Wiley IEEE Press. With that, I'd like to turn it over to Tim to begin today's presentation. Over to you, Tim.
Okay, thank you very much, Mike, and welcome everyone. Thank you for joining us today on this webinar. And as we always do with our webinars, we ask you a question when you registered about how are you tracking your IP and DNS assignments in your clouds. About a third of you are using a cloud IPAM solution, so I presume that's kind of the portal that you would use to register to access to the cloud and create instances, and as you do, it automatically assigns the IPAM, IP address and DNS, etc. So about a third of you just leveraging what the cloud provides already. Another third roughly are undecided as yet in terms of maybe the longer term strategy. Maybe you're just starting to dabble in cloud and so forth. 22% are using a commercial IPAM solution, 11% homegrown, and 3% using spreadsheets. So it's interesting dichotomy there in terms of the use of spreadsheets. We've seen in the traditional enterprise environment it's a much higher number, but in cloud, perhaps because you have the cloud system to some extent automating the IPAM, that migration from spreadsheets to cloud system has occurred, at least in that environment. But as we'll talk through the webinar here, we'll talk about why are people looking at multi-cloud, what are the benefits of such an environment, and then we'll talk about, then shift into the IP address space. So you've got your enterprise traditional space you're managing today. As you introduce cloud environments, now you've got different address space you need to worry about in terms of assigning addresses, and maybe you just rely on the cloud system for that and have that separate from your enterprise, and we'll talk about that possibility as well. Some of the challenges with cloud IPAM in terms of just making sure these critical functions that, when we say IPAM, we're really referring to assigning IP addresses, making sure that there's enough IP addresses, that the IP addresses kind of fall within your routing topology to enable them to be, in essence, connected to your network, of course. And then also on the DNS side, making sure people can reach them through the domain name system lookups to translate host names into IP addresses for connectivity. So that's really what we mean by IPAM. And then so what are the challenges in the cloud environment for IPAM? And then also how does that relate to a pan-enterprise IPAM perspective in terms of looking at all of your address space, not just in cloud, not just in your virtualization platforms, not just in your traditional data centers, remote branch office, etc., traditional networking environments. We're really looking at it across the board, and maybe what are some of the benefits you can tap by looking at your pan-enterprise environment through a single pane of glass. So we'll talk about that as well. And then we'll talk about, lastly, about BT Cloud automation and some of the ways that, with all of the automation techniques that you have available today through various systems, there's still a lot of legwork that needs to be done to automate and fully set those up. And we'll talk about how you can easily plug in the IPAM component of that through our solutions as we get towards the end of the talk here today. And as Mike mentioned, we'll wrap up with Q&A, also provide some additional resources for you for more study. So why multi-cloud? Certainly, giving you that added flexibility. All the benefits of cloud, of course, in terms of elasticity, being able to, as cloud burst, the term Mike used, to say, basically, I just need to add more capacity, for example, let me just add it in the cloud, just by a few mouse clicks, instead of having to worry about all the hardware and the power and the environmental aspects of that. So you reap all those benefits by leveraging the cloud. And then we define, in our premises here, you can define private cloud, and really private cloud, in some sense, could be on-premise. In our talk, we're going to talk about that primarily as virtualization, just to kind of differentiate it, as cloud kind of implies it's off-prem. But private cloud, in that sense, is more within a public cloud service, but using your private address space. So virtual private cloud, for example, extension of your enterprise network into a cloud provider's environment. Hybrid cloud is really the use of multiple technologies, so whether it's enterprise and a private cloud together to host an application. So it's really an environment where you're looking at hosting application across different environments. So enterprise and maybe private cloud, maybe using your own virtualization techniques within your enterprise network as well. And then public cloud, of course, being the AWS, the Azure, the Google Cloud, BT, etc., different cloud providers. And then the idea of the multi-cloud is that you've got a mix and match of all of these things. And maybe for one application, you use a certain combination of public and private cloud or virtualization technique, and maybe for a different application, you might use a different public provider, etc. So you might have a mix and match there, which certainly adds flexibility and enables you to leverage each cloud provider's advantages. So each of the providers offers a unique set of features in general with respect to differentiating themselves with respect to each other, with respect to ease of administration, their ability to performance-wise, and the number of workloads you've got going on, the query performance, for example, user roles and access level, security, and so forth. So leveraging the best provider for the given application enables you to mix and match, if you will, to optimize the features that you're getting with respect to scalability, agility, the other things we talked about. And then also provider diversity in general also improves, availability of services. So for example, if you are, looking to provide high availability for key core services, having that application deployed on multiple platforms certainly is one way to do that, to provide that diversity. So should one platform not be available for whatever reason, you've still got other availability elsewhere. And then from a security perspective also, of course, by having this additional diversity, you want to make sure that you've got obviously some security locked in with respect to the cloud provider, what they're providing, and making sure your security policies cover equality, if you will, across your enterprise network, and for the same application deployed on different platforms, make sure the security is equal in that regard, if not better in certain environments. So that's certainly always a key aspect to consider when you're looking at multi-cloud, and then it also avoids the vendor lock-in, so you don't allow the vendor, your cloud vendor, to have that leverage over you. So you've always got the ability to pick up and move elsewhere. Always a good thing to have that flexibility. So that's why a lot of people are looking at multi-cloud, and I think IDC actually had a recent study indicated that 84% of IT executives are expecting to use multiple clouds from multiple providers. So it really is a case of a hybrid multi-cloud environment. So that's a really large percentage there. So it's certainly a popular trend these days. So let's look at the networking aspects here, and we're going to really focus primarily on the IP address space. The IP address space that you, as the IP address manager, might have to be responsible for managing. And so we've got these three basic domains. We've got the enterprise, kind of the traditional premises-based networking, data center, remote branch, etc. Your public cloud provider, if you want to have a public cloud service, and then the internet, of course. And then back in the day, it was just as simple as having an internet connection, and you had to manage kind of your public IP address space and kind of keep that separate through a firewall, your DMZ, from your enterprise internal space using your private address space. And wasn't that really the good old days, so to speak, when it was quite easy even though we thought that was complex, having to manage the private space within your enterprise and then additionally public space. But then once you bring the cloud into the environment, it gets even more complicated, because now you've got private address space. If you're bursting your enterprise network into the cloud, or just keeping it there, to just add capacity on an ongoing basis, that's now additional address space, presumably from your enterprise address space, because it's in essence an extension of your enterprise network that you need to track and manage, and make sure that it's is accurate, audit, etc. All the things you need to do to verify your IP address space over time. And then if you want to offer enterprise-facing services on the public cloud provider, you would then have the public cloud IP address space that you would at least need to be able to track, and it's really under the domain of the public cloud provider, of course, to route those public cloud their address space to them. But basically, making sure that that address space is also publicized, perhaps in DNS. If you've got a specific application reachable through the internet that you want people to be able to reach through the public cloud, perhaps as well as your enterprise internet access, you want to publish both of those addresses in your DNS, for example. So that's kind of gives you three domains, if you will, of address space that you need to track. But in a multi-cloud environment, now you've got perhaps another cloud provider that you also need to allocate private address space to extend your private cloud for certain applications. And likewise on the public side, if they're also supporting public-facing applications for you, you need to also be aware of the public address space, and so on. So as we add another cloud provider, it just kind of adds to that level. So with the whole multi-cloud environment, you've really added to the number of dimensions, if you will, that you need to track and manage and make sure you've got a hold of with respect to the IP space, as well as the corresponding DNS information. So the reachability for humans to be able to access resources in their clouds through the internet or through the enterprise, really the DNS provides that key linkage. So if we look at that enterprise IP space and DNS impacts, so for your enterprise private space, so whether you're using that on non-cloud, kind of the traditional data network or legacy, some people might even say, but virtualization, again, private cloud, and then also enterprise network extension into the public cloud, kind of the virtual public cloud into the public cloud service. That's all of those domains may receive or require an allocation of your private address space or your internal address space. Most people use private, but we'll just genericize that with internal address space. Now, likewise, from a DNS perspective, really enabling access to query for that information from internally, because it is, again, your internal network. You don't want outside queryers to be able to access that, and then have it so be published internally and resolvable internally as well. Now for the public address space, so again, kind of the traditional old style internet access are obviously still fundamental today for any network operation, but making sure you've got address space allocated for your internet facing services. Also, of course, resolvable through DNS on your external DNS servers, to have that be reachable through the internet, have them be published in terms of the resources you want to expose to the internet, have corresponding resource records for those. And then likewise, as an extension, having public services available on a public cloud provider on your behalf would also require your tracking of the enterprise public IP address space that the public cloud provider has assigned to your resources there, because again, that's out of their address space, but it's obviously pointing to a resource on your side, so making sure that IP address is within your resource record set, for example, for that IP application, so that folks resolving it from the internet can reach that through either your public cloud service or your enterprise network, internet-facing infrastructure, making sure that all is in DNS is a core capability to make sure you've got that added capacity effectively, so that folks can get to either resource equally through, and then based obviously on how you want to steer people, DNS is a great way to do that. So again, this is really just looking at kind of the different domains of address space and corresponding DNS that you need to manage when looking at expanding into the cloud, And again, with multi-cloud, it just kind of adds, another layer of enterprise private address space for your virtual private clouds, and then also for extension of public services to various cloud providers. That's also more address space that you have to keep track of. Now, an interesting aspect of this model, going to involving a separate provider with respect to IP address assignments and DNS, let's just kind of look at some of the core IPAM functions with respect to cloud. And if we look at just the straight virtualization environment, this again is where you're setting up a virtual machine and on your own hardware that you're running, VMware or Zen or Hyper-V, etc. And then you would just instantiate that. You're typically going to be responsible for all the IPAM stuff because it's all within your own shop. So all the subnet allocations to make sure you've got a set of addresses that can be assigned, the individual assignment, the corresponding management of perhaps if you've got those hosts under a different domain, for example, making sure DNS is configured correspondingly, and then as VMs are instantiated, making sure the corresponding DNS resource record gets assigned, and then as it's freed up, making sure the DNS information as well as the IP address is likewise freed up so that it can be reused for a future device that you want to assign, and then managing that capacity so that as you go through the process of creating VMs or VNFs, that there's enough IP address space when that demand hits. So you don't want to be face a situation where you have a demand for a bunch of VMs for a particular marketing campaign, for example, and suddenly you're out of IP address space at the very time you need them. So that's why the capacity management function is important, to kind of make sure that you've got things, keep tabs on your address space usage, and make sure that is there at the ready. And then likewise security, again, just a broad topic here, but with respect to IPAM, making sure you inventory your IP addresses. That's a key aspect to make sure you've got you don't have any rogue devices out there. Also from a DNS security perspective, if you want to assign your resolutions through DNSSEC, or if you want to provide firewalling services for your users, that's also something that from a pure virtualization perspective, you would, as the enterprise IT manager would be responsible for. But as we now introduce the cloud environment, so private cloud in this case, meaning I'm going to extend my enterprise space into the public cloud provider, but it's my private network, my virtual private cloud. In that case now, the subnet allocation, typically you're going to create, let's say 10.1/16, let's say I give my private cloud provider a block of address space. Now when I allocate from there for different availability zones or sub aspects of your virtual cloud, it could be that you assign it, or you could rely on the cloud provider to assign it. So that's why we say either, depending on your model. Likewise with address assignment, you could go either way there. DNS management typically is still going to reside on your case because it's a host you're creating. You've presumably got DNS information you're already managing, your resolvers are already pointing to. So making sure that DNS has the ability to reach the information for those new hosts with respect to the domains that they're in, if they're not in the same domains you already have, and also the corresponding IP to resource record assignment. So that really, both of those functions really falls back on the enterprise to make sure that's in line. And then as that's relinquished, then it likewise comes back to both in terms of being authoritative for that, so clearing that record out of DNS so that it's no longer lookupable, if you will, from a DNS perspective. And then also freeing the IP address space. Now this area, in the old days it used to be I could just, okay, that device has been decommissioned, I'm going to free up the address space and now I can instantly reuse it for somebody else. In the private cloud example, however, it's more of a case where there may be a holdover time to just make sure everything kind of finishes out with respect to cleaning up of that use of that IP address, and there may be a time of 30 seconds to 5 minutes or whatever, where that address is not reassignable because of that timeout function that they impose. So that's why on the address relinquishment, there's also a dependency there on the cloud provider. So they're in essence authoritative for that address, even if you assigned it going in when you created the VM or VNF. Address capacity management really still, although you could rely on your cloud provider for that, but it's a good idea to really keep tabs on that proactively from the enterprise side to make sure, again, you've got the address space when you need it, Security both, so the cloud security provider hopefully providing basic security functions, but obviously you still need to be involved with respect to the other aspects, the IP inventory, the DNS firewalling, etc. And then if we look at a pure public cloud environment where you've got, in essence, internet reachable resources that you've instantiated on a public cloud provider, typically it's going to be from the public cloud provider's address space. So all the IP address space functions are really primarily driven as authoritative by the cloud provider. So an elastic IP address, for example, is going to be assigned to you from the address space of AWS, for example. So the subnet allocation, address assignment, DNS management, likewise. Although, making sure that, again, if you're publishing this in your DNS, that actually could be both, with respect to making sure that if that application, internet reachable application, is also reachable on your internet-facing enterprise infrastructure, then you want to make sure that your DNS kind of covers both of those IP addresses in your resource record set. So that could actually be both there. Relinquishment, both for the same reasons we discussed, and then also capacity management security, likewise mirror what we discussed on the private cloud environment. So you can see that there's a direct dependency. It's not quite the same as managing your IPAM in your enterprise environment, because you now have this additional domain of control or authoritativeness that needs to be accounted for when you are managing your IP address space. So let's just take a quick look at an example here, and we'll see how that works out, this authoritative nature with respect to how you do certain things. And this is we're going to talk about our Sapphire Cloud Automation Appliance, our CAA appliance. We're going to talk about that a little bit later, but it's basically an IPAM automation engine for you to be able to really just have a one call to automate your IPAM functions for environments where you've got multi-hybrid clouds in play. So here we're using an example on the left. So I've got my API client, whether it's Ansible or Chef, what have you, whatever you're using presently. It can make a call to the CAA. Let's say we're going to provision a subnet in this example. Then that subnet, that CAA is going to take that call and, okay, I'm going to go to IP control, which is our IP address management solution here from BT, and it's going to basically make an API call to just give me the next subnet for this virtual private cloud. And so, without having to know what that is in advance, you can just ask for it. It'll give you the answer back in terms of that subnet that it allocates. So your IPAM system is now tracking that subnet, and then going to the public cloud provider, or as an extension, the private cloud, issue that you've got the subnet address from IP control, create the subnet, you get the subnet object back, and you report the result back. So here, in this case, we're saying, using the example of IP control being authoritative for that subnet information, and then I'm passing that information from the authoritative source to my other source, in this case, the public cloud provider. But if we look at the case of an instance, let's take another example, same configuration here. So if I want to create an instance through the CAA, now it goes first to the cloud provider, because now you've got a case where you might have this holdover thing going on that I mentioned, where I've freed up an address a couple of minutes ago, but according to maybe my IPAM database it's free, but maybe in the cloud provider hasn't quite marked it as free yet. So you might have to do a query, what are the free IP addresses, identify a free IP, okay, I'll pick this one, create the instance, get back the object, import the device into IP control, and then report success back. So in this situation, you've got a case where the authoritative source is the cloud provider, and you're really keeping your IPAM system up to date in the same flow, so that you've always got that information there with respect to, no matter who's authoritative for that information, you've got the IPAM information stored, so that, as you need to audit or perform troubleshooting or look at your capacity utilization, etc., you've got the information in your IPAM database. So just getting back to, kind of stepping back from that now, and let's take a look at some of the challenges that we've discussed just a moment ago. Subnet allocation, it's as easy as making an API call for the next one from IP control. But being able to provision v4 and v6 address capacity for your virtualized network functions, or VNFs. The actual address assignment, of course, and then depending on who's authoritative for that, making sure that information is logged down first before the other system is updated. DNS management, of course, provision of DNS domains, association of the resource record based on the IP address assignments, again, to make sure that people can access the resources that you've just instantiated, and then also freeing those up. So when I destroy my VMs or VNFs, having that IP space be freed up, and again, there may be a timer there, so syncing that up is also something that's important to do by tracking the capacity utilization of your IP space, and again, security, for example, from a malware detection perspective, making sure you've got DNS firewalling capability for those devices that are querying out to the internet, to make sure that should there be a malware infestation at some point within your private network, whether on-prem or cloud, you can detect and mitigate that. So some of the impacts of mismanagement, inability to provision your VMs and VNFs on your network. So again, the very purpose of having your elastic capacity is to be able to provision these virtualized network functions when you need them. And so that's where the capacity management comes into play, where you need to make sure you've got capacity there when you need it. Otherwise, you're pretty much out of luck. Suboptimal address space utilization. So again, depending on the size of your network, if you're tightly managing address space, for larger customers, that's sometimes an issue, making sure you've got the capacity aligned, and also from a routing perspective, make sure that hangs together. Unreachability is a potential impact of mismanaging your IP space too. If you end up with a duplicate address assignment, perhaps I thought that address was free, it really wasn't. I've assigned it to 2 hosts, and now I've got an issue with reaching both of them. Also unreachable through DNS, meaning that if I try to look up a given host, maybe the DNS hasn't been updated with the current host to IP address assignment. Maybe I had to destroy that VM and recreate it on a different provider, what have you. So being able to kind of change the IP address that host points to in DNS is crucial to keep that up to date, and if that's not done, your VNF will not be reachable. Hampered troubleshooting, again, having that information in a centralized IPAM database is critical to be able to look up an IP address, because if you're not able to reach the destination that you're trying to troubleshoot because that's probably part of the problem, it's a good idea to know what IP address it's supposed to have there, in case there is perhaps a backdoor through a dual stack interface or what have you. Wasted address space reduces capacity. Again, if you've got a bunch of address space allocated to virtual private cloud X, and you need a bunch in virtual private cloud Y, you need to, really that doesn't help me if you've got all this extra space over there unless you go back and carve it up and reassign it. But again, that's really something you can keep track of with an IPAM system. And then increased vulnerability, again, getting back to the security aspect. So as you add more machines or resources in the cloud, that's really, in essence, increasing your attack surface, if you will, or increasing the number of candidates that can be attacked. So just making sure, again, they're equally secured with respect to what you've got on your enterprise network, or in accordance with your security standards, to make sure that those are equally secured with respect to with respect to your security plan. So if we look at, again, the multi-cloud, hybrid multi-cloud environment and managing IP address space, your enterprise non-cloud, you've got address space that's assigned through DHCP. A lot of folks use DHCP or statically assigned. Through virtualization, pretty much the same thing. You can do it manually, or through DHCP using homegrown or home implemented virtualization technologies. And then AWS, Azure, just to kind of use 2 examples of public cloud providers, again, using primarily manual methods to assign individual IP addresses. There's really no DHCP per se in those environments. So that's kind of, so if you kind of manage these individually, you kind of end up with these 4 pillars, if you will, or these 4 silos, so to speak, where you might be managing. So for those of you in the registration who indicated you're using a cloud provider, well, that's great. You can log into the portal and check the IP addresses and so forth, but you might not necessarily have a view of how that might overlap with what you have on your private cloud or your enterprise virtualization systems or your enterprise. So having that be really across the board through a pan-enterprise IP space visibility gives you the ability to now look at the address space across the board, across your traditional enterprise networks, data centers, remote offices, virtualization, as well as your private clouds, and also publicly accessible resources on public cloud service providers. So having that ability gives you a lot of benefits. You've got the ability to, of course, inventory your IP space across all of your domains, So making sure you don't allocate a subnet in a duplicate fashion, which certainly would be an issue if they're all connected on the same routing plane. And then being able to manage those subnets, making sure you've got adequate address space for VMs. So when you do need a burst of VMs or VNFs, having that capacity at the ready is critical. Host address assignment, again, being able to configure that through the example I mentioned through the CAA. You can now roll in your public and your public cloud providers into that process to make sure that you've got the information, the address assigned by the authoritative source and then tracked in your IPAM system. Likewise with DNS updates, so whether you're relying on the cloud to publish that or whether you're publishing that in your own DNS servers, making sure that information gets there in a timely fashion so that when the IP address is assigned to a given host, that host to IP address association is updated in DNS and is accessible by the users who need to reach it. Overall, IPAM benefits, really just, rolling in cloud can kind of enable you to reap these benefits across, again, your PAN enterprise environment. So automating the cloud IP initialization, as I reviewed through that flow there, just by one call into the cloud automation appliance can really help you automate that process to really handle the IPAM aspect. It gives you that PAN enterprise visibility of your IP space in DNS. So again, you've got a single source of authority there, regardless of who's authoritative for the assignment. Security, really a key aspect. So inventory is a big thing about keeping track of what's where. An IPAM system can help you do that across the environment, as well as other security services like DNSSEC or DNS Firewall, etc., all supported by a good IPAM system such as ours. Reporting, auditing, administrator scoping, who can do what. So if you wanted to allocate your cloud space to another cloud administrator, that could easily be done just through administrator scoping, but you still get the centralized or core database functionality within the same system. Scalability, again, really need this for leveraging the cloud benefits as well, adaptability, integration through a graphical user interface, through a REST API, cost and time savings through the automation, and improved troubleshooting. Again, having that centralized repository is key for that. So if we look at, in terms of the network services and initializing, automating the assignment, so from an IP address capacity management perspective, looking at the IP addresses out there, making sure that I've got enough IP address space according to what I think I need in the future, allocating subnets, so just saying, hey, give me the next subnet, making that simple, being able to split and join space. So if you do have excess capacity in one domain, you need to move it elsewhere. Splitting and joining or reallocating space is quite helpful there. Individual address assignment, so again, having the API automation to assign the IP upon VM instantiation is critical so that the device can be reachable on the IP network, of course, and also making sure that information in DNS is likewise updated so that it can be reachable by humans, not just by IP address, and folks can reach it through the host domain name that you assign to it, and through the quick DNS lookup gain access to it directly. So from a BT Diamond IP perspective, we support the hybrid multi-cloud IPAM integration, automated subnet assignment as we illustrated earlier. We do also enable a reconciliation type feature where you can kind of compare your subnets that you've got allocated to your cloud, both in the cloud system versus what you've got in IP control, compare them, and either update IP control or just give you a report of that. So that's very handy to make sure you're keeping your inventory, make sure you've got no rogue assignments out there. Comprehensive IPAM DDI features, so really just providing the full stack of IP address management, so from app block allocation down to individual assignment, discovery, to be able to identify devices once again for that report, and also the reconciliation and reclaim. So again, over time, it may be that devices that you thought had deassigned haven't timed out yet, so maybe there is still actually a VM running on that IP address or not, but it would give you that information to be able to look into that and perhaps reclaim that address. Having alerts on your capacity, so that's helpful with respect to being notified in advance without having to go in and look every hour, for example, and you're given subnet utilization. Having those capacity alerts is very handy there. Then, of course, obviously supporting DHCP, DHCP6, and DNS. So we support these natively in our product. Again, DHCP is not so much useful in the cloud environment. given the use of really kind of a manual assignment during the creation process. The DNS is certainly indispensable across the board in all of these various domains. So that's critical to keep track of there. We also do offer virtualized DNS, DHCP, IPAM, and our CAA appliance itself is also available on a virtualized platform. So that includes not only the virtualization, kind of the in-house virtualization technologies such as VMware, Xen, Hyper-V, and Oracle VM, but also on the public cloud domain with respect to AWS and Azure, as well as the BT Cloud Compute environment. So anywhere you've got one of those services that you're running, you need to instantiate, a DNS appliance. You can just, again, instantly instantiate that as you can any other VM in your public or private cloud environment. And then also the IPAM executive for tracking, maybe for a backup as a redundant database, as well as your CAA for redundancy and added capacity there. So very flexible, and it gives you all the benefits that you get from cloud as applied to your IPAM solution. Of course, reports, administrator controls, extensible APIs, and workflow. This is all part of our basic solution with the addition of the cloud automation appliance. Then, of course, DNS security with respect to DNSSEC, automating the resolution of that, and then also the DNS firewall. To make sure your resolvers, if there is any shady business perhaps going on, making sure you have a heads up to that to detect possible malware infection, and then be able to at least investigate it, mitigate the device, take actions to make sure that it's been taken out of your network. So our cloud automation appliance, so again, we showed an example where it kind of fits in the flow. So it really gives you a way to kind of plug it in with respect to having it take care of all of your IPAM operations with respect to your cloud provisioning and cloud management tasks. So it integrates the cloud and IP control APIs. It provides customizable logic. So basically, using a drag and drop interface, you can string these together. We've got a number of primitives, as we say, or API calls that we've programmed in natively in the product that you can basically just drag them over from the left pane to the right, plug them into your workflows, and basically define how you want it to work. So the flow that I illustrated earlier for creating a subnet or assigning an IP address, you can actually modify that, create your own, do it the other way, however you want to do it. It's very flexible, and it's very extensible, and of course scalable. And then it also supports redundancy, so you can have multiple CAAs, multiple IP control executives, so it gives you that added resiliency with respect to being able to keep your IPAM functionality going in the face of a particular outage for perhaps somewhere. But the bottom line is it gives you that automation. So once you've got these workflows defined and available, you can basically make your call, have the IPAM automated through IP control and the CAA, and have the rest of your cloud operations work in harmony. And I'll just wrap up highlighting some of the resources we have. We have a cloud network services, core network services cloud automation white paper. The second draft of that is available, or version rather. So we welcome you to download that on our website or contact us for that or other information. Various other white papers are available on IPAM, IPv6, DNS security. The books Mike mentioned, of course, we're on LinkedIn. I've got a blog on Let's Talk, which is BT Let's Talk, as well as the IPAM Worldwide one. And then our website, of course, is www.btdiamondip.com. And with that, I will hand it back over to Mike, and we'll head to Q&A.
Okay, thanks, Tim. So again, to ask a question, you may type in your question in the chat pane on the WebEx application. And we have a few questions here that I see, so let's just start right off. First question is, can I use DHCP for IPAM or with IPAM in the cloud?
Okay, that's interesting. Well, it depends. I think, again, in the cloud, if we look at a public cloud provider, it's not typically used. I mean, there's in an enterprise cloud or enterprise virtualization platform environment, you might have kind of a virtualized DHCP function like VMware, for example. But in a public cloud provider, in fact, I think that Azure doesn't even permit DHCP traffic. They can actually shut down the port and don't allow broadcast traffic, etc. So
So I think they're talking about like implementing a DHCP server, right, in the cloud.
Yeah. So if I instantiate it via a DHCP server, I'm not going to be able to run traffic to it if I'm using the
not Azure, right? Azure.
Not Azure. Yeah. I'm not sure about AWS if they do, but but back to the questions about using it for IPAM. I mean, I think within the traditional enterprise network, it's really one of the workhorses, if you will, to assist IPAM. I mean, there's still a broader IPAM function on top of DHCP to make sure that the address pools you have provisioned fit in with the overall address plan, so that the devices connecting through DHCP get an address that's relevant to where they are, that they can reach other enterprise destinations, the whole routing bit works in with that as well. So there's still a need for IPAM configuring DHCP just in a traditional enterprise network, and it applies equally if you are able to deploy DHCP in the cloud of your choosing.
And you want that global view of the address space regardless of where.
Yeah, exactly. So if you do implement DHCP, I mean, you can as I mentioned, you can instantiate our DHCP server, our Sapphire DHCP in the cloud, where it's permitted to be, accept DHCP traffic by your cloud provider. So you can certainly do that, but it's really just one component of your IPAM strategy that we would recommend.
Yep, okay, good. Let's see, next question. Is your cloud, I think this is a product-specific question, is your cloud automation appliance like Ansible?
Yeah, so Ansible, I guess, is one of these configuration management systems, and I kind of showed that in the diagram to the left, and it's basically really a broader system. Ansible is more, it's really a great tool to be able to automate functions that, repetitive functions involving, you can really program a lot of details in there and the workflows, but really our view is the CAA is almost the Ansible for IPAM, if you will. So it's really just focused on IPAM aspects, so it enables Ansible to call it, for example, hey, get me a subnet, and the CAA will figure out, based on your, the public cloud provider, IP control, coordinate all that, report the answer back. So a single call from a system like Ansible for creating a subnet and IP address, reconciling address space can help to simplify your Ansible configuration. And then as we talked about, the CAA is quite easy to set up and configure as well, so that they can link together, really, in essence, delegate the IPAM functionality for your automation for the broader workflows that you have in Ansible or Chef or Puppet or whatever you're using.
Really complementary.
Yeah, exactly.
And you can take all that domain IPAM logic and put that into the cloud automation appliance, and then keep it out of Ansible, just have Ansible make simple calls, right?
Right, exactly. Have Ansible coordinate the other activities.
The DevOps, yep.
Yeah,
that's cool.
Exactly.
All right. Let's see, next question. I just allocated space to my cloud team and let them handle IPAM. Do you see any issues with that?
No. Well, I think... So I guess the implication there is that I got a cloud team and they say, hey, I want to play around with the cloud, or I want to implement these applications in the cloud, and you're just giving them a block and saying, go have fun with that. I mean, that's okay. I think, you kind of get back to the issues of if it, I guess there's kind of two ways to do that, right? You can use, like, let's say IP control, a system that we enable you to kind of do that delegation. Like I can say, here's a block, go have fun with that, but make all your changes through the CAA so that it gets reflected in IP control. That way you still have visibility to the assignments, the capacity, make sure hey, if you guys need more address space over there, and you can proactively stay on top of that. Whereas if you just kind of let them run with their own IPAM, maybe they're just using the cloud IPAM system, and I'm just going to consider this block I gave you as fully, I'm going to kind of make sure I don't reassign it so you don't have that duplicate issue. But you kind of lose that visibility into what's going on. And it's not just being nosy, it's also about auditing and security, tracking your inventory and your capacity. So, we would recommend, I think doing that in principle is certainly something that a lot of our customers do in terms of delegating responsibility for different address spaces for different environments. But making sure that you have that tracked still within the centralized IPAM system is important for those other added benefits that we discussed.
Yeah, well, I mean, just one other thing that comes to mind, because you talked about this, if you're using multiple, cloud providers, now you have a different group for one cloud provider, a different group, now you have, different views, each of the cloud providers and your IPAM system, so.
Right, you end up with a mishmash.
Yeah, mishmash, and it'd be nice to have, at least have a view of it all within, your single IPAM system, so.
Yeah, exactly.
Yep, okay.
Yeah, that makes sense.
Good, let's see. The next question is, you mentioned security. What about it? Could you elaborate?
Yeah, in fact, it's, obviously security is a huge topic, and Cloud IPAM can help enhance your security in a number of ways. So keeping track of inventory is clearly one of the key aspects of security. So you're really looking at what have I authorized to run on my network, and being able to track the IP address that I've assigned, so that you don't either lose a device that you think should be there, or you have another device that shouldn't be there, and really having that inventory tracked over time and audited is one way to help detect possibly an infiltration within your network. So that's one aspect. I mentioned DNS as well. So if you're running DNS resolver services in the cloud, for example, for any virtualized network functions running there, that you just want to have a DNS server locally that they can access to issue queries out, or within your network for that matter. You can enable DNSSEC as well as DNS firewalling, again, to detect any malware queries that might be coming in. The DNS firewall is updated several times a day, several times an hour in some cases, depending on what's going on, and that just provides an up-to-date mechanism to help you identify potential infestations and be able to track them down and rectify the issue and mitigate it. So, before it has a chance to spread and perhaps do more damage on your network. So, security is definitely a core topic across the board when you're talking networking, and as you expand the availability of resources into the cloud, it definitely adds the opportunity for an attacker to have more targets, so to speak, and so what the cloud provider provides you is also important to consider, to make sure that you've got the basic ports and protocols that you're permitting through and across, as well as the other measures we discussed.
All right, thanks. Next question. I think you've answered some of this already, but what are the benefits of multi-cloud IPAM?
Yeah. So basically, this one might have come in right at the beginning. I thought I saw something coming in there. But anyway, multi-cloud IPAM uses the flexibility to deploy, different, applications across different sets of clouds, or different, combinations of enterprise and cloud, for example. So a given application might be database intensive, and you want to use the cloud provider that provides you the best performance from a database perspective to supplement your enterprise deployment. So you might have a deployment of this database application within your enterprise data center, as well as in a particular private cloud portion of a public cloud provider. So you want to make sure that you can manage that. That gives you the ability to optimize the performance of your application, but also have the benefits of cloud with respect to the elasticity and performance and so forth. Whereas for a different application, you may have a high rate of I/O and queries and answers, and so you might want to use a different provider. So it's just being able to use multiple clouds based on your optimal choice of their ability to meet the requirements of your application just gives you that added flexibility that cloud in general provides you, just to another dimension. So that's really some of the core benefits. I mean, using the best of breed, making sure you don't get locked into a vendor, and also just being able to track that. I think the other aspect of hybrid cloud IPAM is if you're cloud bursting to add capacity for a given application. I kind of discussed this earlier as well. It's just if it's a public facing, or even within your private network, just making sure that application instance, let's say it's a given app1.bt.com, for example. That's my application name. I want to make sure that the IP addresses, the VMs that I've instantiated for that application, tie in with that in DNS to make sure that app1 has an IP address for your cloud, reachable VNF or VNFs, and likewise for your enterprise space. So making sure you've got the IPAM to manage that multi-cloud environment, which I think is the crux of the question, is really critical there as well, to make sure your users end up being able to reach multiple destinations through the same domain name.
Yeah, and besides the diversity, I wonder if cost comes into play there. Like if it gives you the option to look at, based on your specific applications, the cost between one provider versus another.
Yeah.
Potential for, cost savings by, hosting some applications on one provider and others on another, so.
Yeah, oh no, that definitely,
Yeah.
that was almost too obvious to put on the list, but.
Yeah. All right, let's see, I see one more question here. Can you elaborate or explain the difference between hybrid cloud and multi-cloud?
Yeah, I kind of munged these terms together, hybrid multi-cloud, but there is somewhat of a distinction. I think hybrid cloud is more around, for a particular application, I'm using a hybrid cloud approach. So it's more, again, for like the database application we talked about. I might have an instance of that application on my data center. I might have an instance of it running in my public cloud provider. And so I'm using kind of a hybrid approach there, where I've got a kind of a virtualized instance. I've got one in AWS, for example. And then I might have a different, Microsoft application where I might have it also running in my data center, but also cloud bursted over to Azure. And so, that's another case of a hybrid cloud implementation, or you might have the same service running across multiple cloud providers, maybe Google Cloud or what have you, BT Cloud Compute. And so you've got that diversification, again, the cost optimization, feature optimization. But that's really the idea of the hybrid cloud, is that for a given application, I'm using multiple technologies or multiple domains, and the multi-cloud is more of a, well, on an aggregate sense, I'm using multiple cloud providers to really manage or track my enterprise network. So I've got multiple clouds, but for a given application, I might be using just a subset of those for the various reasons, for performance, cost, etc., that are important for the performance of that application. So that's why I kind of munged that hybrid for a given application, multi-cloud across your application. So it's a hybrid multi-cloud IPAM, but that's really the distinction there. Hopefully that's a little more clear now.
Okay, thanks. So let me just check to see if there's any more questions here. Okay, next question. Is the CAA needed, or is its functionality available as a piece of software that could be installed next to IP control?
Okay, well, piece of software. So the CAA, the Cloud Automation Appliance, with the workflows in there and the pre-canned, if you will, workflows that we have, is an appliance. It's also available as a virtualized appliance, so it can be made available as, quote, software, but running on a virtual platform. And again, it supports all the virtualized platforms that we discussed, VMware, Zen, Hyper-V, Oracle VM, Azure, AWS, but as we don't offer it as a software licensable component like we do our IP control software. So it's more of an appliance implementation.
Well, I guess there's a lot of logic that's built in, into the CAA, that if you didn't use the CAA and just used, interfaces directly, that you wouldn't get. Yeah,
I mean, I think if you wanted to, obviously, our IP control has APIs. So if you wanted to kind of, you're certainly welcome to leverage that. That comes free with the product. So you can leverage those API calls and, in essence, build, your own multi-step workflow using, some of the other tools, Ansible or whatever. So you can, in essence, emulate what the CAA is doing through software, through other workflow systems. But the CAA just has the benefit of saving time. It's got a lot of that automated already. It's got the verified,
graphical user workflow, drag and drop. So it just makes it
extensible. So
quicker, faster.
Yeah. So that's just another. So, and the appliance approach, virtualized, it just gives you that the added security and so forth that we provide with all of our appliances, and so it has that benefit as well. So, and that's actually, getting back to the security question, I didn't really address, is just the appliance itself. So our virtualized appliances, of course, have this same set of security requirements that our hardware appliances have, and so that includes the operating system. It's not built on a standard distribution. It's a Linux, basically raw Linux kernel that we've built from scratch with respect to adding in the functions that we need and nothing that we don't, and also locking down from the ports, the file system, the users, etc. We've got rate limiting on their ACLs on the interfaces, so it's got a lot of security features built in that you wouldn't have to worry about when implementing just a software. So whether it's virtualized or hardware, our appliances are purpose-built, secure appliances.
Okay, great. Let's see. I think that's we're running out of time here, so that If we didn't get to your questions, we will follow up with you directly over the next day or so. I'd like to thank Tim for his presentation today, and I'd like to thank all of you for participating in this webinar. We hope it has been beneficial in helping you understand how automating core network services can improve your cloud operations. Thanks again, and have a great day.